Hey guys, let us start with solving question based on indeterminate form. Our first question is question number 1, that is, if f of x and g of x are two functions such that f of a is equal to 0 and g of a is equal to 0, then what is the value of limit extending to a f of x upon g of x? We have to find the value of this. Actually, if f of a is equal to 0 and g of a is equal to 0, then limit extending to a f of x upon g of x becomes 0 by 0 form, which is indeterminate form. So we have to find its value. So here we are expanding the given function in neighborhood of point A by using Taylor series expansion. That is, we know that if f of x is any given function and it is nth time differentiable, then we know that its Taylor series expansion is f of x is equal to f of a plus x minus a into f dash of a plus x square by 2 factorial f double dash of a, and so on. Here we have to find the value of limit extending to a f of x upon g of x. So first of all, we are expanding this function in terms of Taylor series about a point A. So this can be written as f of a plus x minus a into f dash of a plus x square by 2 factorial f double dash x minus a square by 2 factorial f double dash of a, and so on. Similarly, g of x can be written as g of a plus x minus a into g dash of a plus x minus a square by 2 factorial into g double dash of a, and so on. As f of a is equal to, it is given that f of a is equal to 0 and g of a is equal to 0. So this value becomes 0, this becomes 0. So this limit is nothing but limit extending to a. This is 0, this is 0. So only remaining part is x minus a f dash of a plus x minus a square by 2 factorial f double dash of a, and so on. In denominator, x minus a into g dash of a plus x minus a square by 2 factorial into g double dash of a, and so on. If we divide numerator and denominator by x minus a, then we will get this x minus a will get cancelled. Here in numerator and denominator, coefficient of f double dash of a and g double dash of a only remains x minus a, because one x minus a is get cancelled. So this becomes limit extending to a f dash of a plus x minus a into f double dash of a, and so on. In denominator, g dash of a plus x minus a, this is 2 factorial, this is 2 factorial into g double dash of a, and so on. If we substitute its limit, that is extending to a, if we substitute x is equal to a here, then this value becomes 0, and obviously remaining all other terms also become 0. So only remaining part is limit extending to a f dash of a upon g dash of a. So this is the value of limit extending to a f of x upon g of x. So this is our final answer. Next question, that is question number 2. In question number 2, it is given that if f of x and g of x are two functions and f of a is equal to 0, g of a is equal to 0, f dash of a is equal to 0, and g dash of a is equal to 0, then what is the value of limit extending to a f of x upon g of x? As we have seen in question number 1, that is, our value of limit extending to a f of x upon g of x is f dash of a upon g dash of a. But here f dash of a and g dash of a also 0. So we have to divide numerator and denominator in previous series, that is in Taylor series expansion, by x minus a square. So our remaining terms is only f double dash of a upon that is a limit extending to a f double dash of a upon f double dash of x upon g double dash of x. That is f double dash of a upon g double dash of a. This is our required answer. Next question is also similar. That is given that if f of a is equal to infinity, g of a is equal to infinity, then find the value of limit extending to a f of x upon g of x. This value is also similar, that is the limit extending to a f dash of x upon g dash of x. This is actually a L'Hopital rule, so we can prove this problem also by in similar way as previous. Next question, that is question number 4. In question number 4, we have to find limit extending to pi by 2 1 minus sine x upon cos x. So we have to find the value of this function as limit extending to pi by 2. So first, if we put x is equal to pi by 2, then this numerator becomes 1 minus 1, that is 0, cos of pi by 2 is 0, so this is 0 by 0 form. So if function is given in the form of 0 by 0 form, then by L'Hopital rule we have to differentiate numerator as well as denominator till 0 by 0 or infinity by infinity form get removed. So this becomes, by using L'Hopital rule, differentiate numerator and denominator. So this becomes limit extending to pi by 2 minus sine, derivative of 1 is 0, derivative of minus sine x is minus cos x, derivative of cos x is minus sine x. So if we substitute x is equal to pi by 2, minus minus get cancelled. If we substitute x is equal to minus pi by 2, so this becomes cos of 0, cos of pi by 2 is 0, sine of pi by 2 is 1. So this is 0 by 1, and 0 by 1 is nothing but 0. 0 by 1 is 0. So our correct answer is this. Next question, that is question number 5. In question number 5, we have to find limit extending to 0 sine x by x. If we substitute x is equal to 0, then sine 0 is 0. So this is again 0 by 0 form. So to find out its limit, we have to differentiate numerator and denominator till 0 by 0 form, and infinity by infinity form get removed. Here function is only in 0 by 0 form. So by using L'Hopital rule, differentiate numerator and denominator. So derivative of sine x is cos x, derivative of x is 1. So as extending to 0, cos 0 is 1. So our final answer is 1.